afternoon, sir. I am audible. Good afternoon, sir, madam. Vignesh, sir. Vignesh, sir.
Vignesh sir. Vignesh sir, are you there? Wait a minute. Vignesh sir. வந்துட்டேன்.
வேற ஏதாவது குரூப்ல போட்டோம், கால் பண்ணி போட்டோம். Yeah, very good afternoon to all. External is yet to arrive. Please wait 2 minutes. External having some network issue. Currently, he talked to me over phone. Yes, will be joined. Sir. FTP start political, sir. 5 minutes to start political, sir. FTP is starting time.
These things happen in the problems.
low. Yes, here. Sir, good afternoon, sir. Yes, sir. Yes, sir. Yes, sir.
Good afternoon, sir. I've joined. Am I audible?
Yes, sir. Yes, sir. Shall we start?
Yes, please.
Yes, sir.
Good afternoon to all present here. We are now going to start the session. We cordially welcome our respected guest, Dr. H. Vignesh Ramamurthy, sir, of this session. The topic of the today's session is Vector and Google Lambda. Now I invite Dr. Karthik, sir, to address the speaker, Dr. H. Vignesh Ramamurthy, sir.
Welcome to all. I'm glad to introduce our resource person of this session, Dr. H. Vignesh Ramamurthy. Currently, he is working as an assistant professor at the Department of Information Technology and Cognitive Systems, Sri Krishna Arts and Science College, Kanpur, India. He has obtained his PhD from Bardha University, Kanpur. His areas of research include mobile computing and networking, artificial intelligence, teaching and learning pedagogy. He has published more than 45 research articles in the reputed international journals like SCI, Web of Science, Scopus, and UGC CAR journals. He has 12 years of experience in teaching and research. He is an editor and reviewer in more than 30 international reputed journals. He has participated and presented more number of research articles in the various national and international conferences. He has given more than 50 invited talks in various national and international conferences, including invited talk on the topic Cognitive Systems at All India FM Rainbow Radio, Coimbatore, held on 22nd February 2020. He has participated in a TV show titled Napal Mudiyum, organized by Target Zero, an environment and wild conservation trust, presented by Pudhiya Thalaimurai television on 13th October 2018. He has conducted nearly 50 invited talks and webinars. He trained 50 students of Jamaica, North America, on web through online mode and educational visit to Brighton University College, Malaysia. He was honored by the institution for his excellency and contribution in various fields, such as 7 Best Paper Awards for Conference Papers, Pudit Kona Award, Young Educator and Scholar Award, Best Faculty Award, Dr. APJ Abdul Kalam Young Teacher Award, Outstanding Educator Award, and Best Research Scholar Award by Indian Academic Researchers Association, April 2019. We are very grateful to welcome you, sir, on this wonderful session of this online international faculty development program on current trends in applications of mathematics. Thank you, sir. So, over to Dr. Vignesh Ramamurthy.
Thank you so much, and very good afternoon to one and all joined here. So let me share the presentation now. Good afternoon. I'm Dr. Vignesh Chamamurthy. Today we are going to discuss on the topic Google Lambda and vectors. So we'll cover. Is my presentation visible?
Yes, sir. Visible, sir.
Yeah. Okay. Fine.
Yes, sir.
So today we'll cover what is artificial intelligence, a brief introduction of artificial intelligence, and how AI is related to machine learning. And we'll see what is Google Lambda, how this AI applications are incorporated in Lambda, and we know what is vector in terms of mathematics. We'll discuss on the connectivity of vectors in Google Lambda. So this is our agenda. This is what we're going to discuss today. As I mentioned earlier, we'll start with artificial intelligence. You know what's artificial intelligence? Because now the current technology, everywhere you can see the evolvement of AI, artificial intelligence, and many applications on artificial intelligence. So as the father of AI defined, Mr. John, researcher John McCarthy has defined AI as the science and engineering of making intelligent machines, especially intelligent computer. So you have to make the machines to think and work like human being. The decision-making skills of human being should be incorporated and depicted in machines using the computer programming languages. That can be any programming language. So artificial intelligence is a way of making a computer that can be any machine. A washing machine is a smart washing machine because of this embedded system, the computer programming. So there are some washing machines now released by the vendors, which you call it a 6th sense washing machine. So how a washing machine is going to think? So based on the type of the cloth, okay, the machine will set the temperature for the water and it will rinse the clothes. So this is one example of making machines intelligent. In same manner, you can concentrate on all the machines and make the machines to think and work and depict some of the important intelligence skills of human beings. That can be a decision-making skill, that can be a thinking skill, or that can be a skill to reply to the questions as things. You would have interacted with many automatic chatbots. So when you have a conversation with a human being or you have a conversation with a chatbot, what is the difference? So chatbots work based on the data that is stored in the repository. That can be a database or some repository. So this is a simple method of retrieving data from the database. Okay. So how the machines can be effectively used to automate the process. This is all about artificial intelligence. Need not to be a robot, it can be any machine. So life was programming with and without AI. So without AI, it could be answering the specific questions, whereas with the help of AI, it might be generic. You'll be getting the answers as generic. And modification in the program leads to changes in the structure in AI, but in programming with AI, it can adapt to new modifications, new changes, and it's going to be highly independent. And without affecting the structure, the modifications can take place. So adapting to the new changes is itself a learning. it is one important aspect of artificial intelligence. And in this side, the modification is not so easy. It needs whereas programming AI modification is quick and easy. So these are major areas of artificial intelligence, like expert system, where there is a data repository created based on the expert knowledge. And twin peering is one of the biggest industry in artificial intelligence to create games, and computers play as an opponent with the human being. So you could see games like Rummy, online games, many online games like Rummy, and where the machines are playing with human beings. There are multi-players connected, and the computer is also one opponent which will play along with the team. And a lot of games with high-end graphics are created using the artificial intelligence. And natural language processing to process the natural language. So we have regional language. There are different types of languages. Say, for example, in Tamil Nadu, language from Madurai, language from Coimbatore, and language of Chennai, each have its own unique pattern of language. So to process this data and process this natural language and to convert into useful information or to convert into a proper data, you need the machines to be capable of understanding language and converting into maybe a textual form or in a graphical form. So this is all about processing the natural language, which involves a lot of computations, wherein mathematics and computer science have to play equal roles, and they should go hand in hand. Next comes the speech recognition, understanding the voice and converting those voices into appropriate words, recognizing the speech. This is also one major application of artificial intelligence, and one is computer vision. Computers don't have eyes, so cameras are installed, and here we have this image processing with the artificial intelligence, and the processing is done. And finally, the robotics. You can combine everything and give a humanoid robot, and all the manual process can be converted into automation process. So this is how the AI embedded with machine learning and deep learning. So you could see deep learning and as a core of AI and ML. So ML is machine learning and DL is deep learning. So artificial intelligence is a broader area which has a lot of programs that can sense, reason, and act and adapt, in which machine learning is part of AI, which involves many algorithms, a lot of algorithms that to improve the performance and to get the data and to automate the system. And deep learning is a subset of machine learning in which multi-layered neural networks learn from vast amount of data. Okay, so this is how the artificial intelligence, machine learning, and deep learning are connected or joined together. Okay, so let me show you the evolution of AI and this is how the evolution has taken place. So from 1950 to 2017, the AI, the engineering of making intelligent machines and programs, and machine learning, the learning ability and bringing out many algorithms to process the machines, to process the automation, and deep learning, which works based on the neural networks. Neural networks looks like artificial neurons. It's a depiction of neurons present in the human body, which is going to process the data quickly, and it has the self-learning and adapts a new changes. Okay, So a small example of machine learning and deep learning in AI. So this is going to differentiate the machine learning and deep learning. This is an input. Input is a car. So we have to perform the feature extraction and classification in machine learning. So this feature extraction and classification happens together as a single module in deep learning, and we get the output. So there's small difference about the machine learning and deep learning. Okay. So another example of pattern recognition of machine learning in the artificial intelligence. So you could see a lot of scripts on the screen. So your mission has to find out the number two. Okay. So 2 is an integer. Okay. 2 is a number. So among the patterns, various scripts or patterns, it has to find out the correct patterns. This green color rectangle can show the different patterns of number 2. So the number 2 can be written in different forms. So the mission has to be capable of finding out this pattern. And there are other notations or symbols which are marked as red in color. This also looks like the actual number, but the quality of the pattern is deviating. So 2 different colors are given here. One is green to say it is or show it is approved, and the red one which can be approved after the human intervention. So this is an example for machine learning and the patterns. Now we'll get back to, so as I mentioned, the 4 phases which we have to have a discussion in the presentation. One, we started with AI when we have completed that portion. Now we'll go for the second portion. So there are four portions to cover. One is AI, and second one is machine learning, and third one is Google Lambda, and fourth one is how this Google Lambda is connected with data. So what's full data in Google Lambda? So machine learning, you have to make the machines to learn with the data. So human beings can learn automatically. How you prepare the machines to learn? So there are machine learning is a subset of AI. It is concerned with development of algorithms which allow the computer to learn from data and past experiences. So the data which is fed by the human beings will help the machines to learn. Not only that, it will help you to adapt the changes, accomplish the task, and do some automations based on the past experiences. So this is to help the machines to learn and to adapt to the new environment, new circumstances, and help in solving the toughest problems, complex problems, and do decision makings like human beings. So this term, machine learning, was introduced by Arthur Samuel in 1959. And we have 2 types of learning in machine learning. One is supervised. The other one is unsupervised learning. So supervised learning is a machine learning method. Here the models are trained using label data. So you will be having the label data which will do the mapping to the functions. Say for example, you have an input variable and an output variable. So the mapping is done here. So supervised learning involves a supervision to train the model. So there will be a supervisor that can be a human being or a different machine which is already already incorporated machine learning and has the intelligence. So somehow there should be a supervision happening in the in supervised learning. This is an example for supervised learning, and as I told you, there should be labeled data. So we are having the input data as we have some apples here, and among the input data, you could see there are many fruits mixed up. We have the apple and banana. So the model has to find out the supervised learning. So we know the data. This is because of the past experience, and this is because of the label data. The machine can find out the apples. So it has to differentiate the apples and differentiate the bananas. So this is one type of classification of data. Next comes the unsupervised learning. Here it follows the patterns, and there are no label data. So in supervised learning, we have the label data. In unsupervised learning, we don't have labels, and there is no supervisor added. So that's the main difference. Unsupervised learning does not require any supervision. So it does everything automatically because of the patterns. So you fed the data, you create the patterns and make the machines to learn without the labeling of data, and it has to learn by itself automatically and perform the operation. This supervised learning. This is one for unsupervised learning. See, raw data and the input raw data. You can see there are cats and dogs. Cats and dogs is given as the input data, and this machine has to process it. And we could see how it is processing. So there is no labeling of data. It is not required. And there is no supervision also. So no labeling of data, no supervision. That's not happening here. Okay. So the algorithm which you're using for unsupervised learning has to find out the data without the label and without the supervision. It has to process. That is, it has to do the interpretation and process it and take the data. So you could see the output, dogs and cats are separated. Now let's go back to the comparison. So in this diagram, you could see supervised and unsupervised all together in the one picture. So the upper part shows the unsupervised learning, and the second half shows the supervised learning. You don't have a supervisor, is it learning, or it can be another program that can be another. So all things because of these algorithms is going to help us to do the self-learning and do the automation. Now we'll compare the supervised and unsupervised learning. The main thing about the learning supervised and unsupervised is, first thing is no labeling of data in unsupervised, which has unlabeled data, and in supervised you have labeled data. And there is no supervisor in the unsupervised learning, and there will be a supervisor. There can be a computer or a human being or an administrator or whoever, or a data architect or an AI engineer or an AI scientist or whoever it is. Supervised learning will predict the output, and unsupervised learning will find out the hidden patterns of the data. And input in supervised learning gives the model along with the output. In supervised, this is happening, and in unsupervised, only the input data is provided, not the output. And the main goal of supervised learning is to train the model. So here the training is happening to make the machines learn and capable of do any complex tasks. And in unsupervised, here it has to find out the patterns and useful insights with the unknown data set. So the data set may not be clear. So with the available data set, it has to find out the exact or approximate hidden patterns. So as I told you, there will be a supervisor to train the model in supervised learning, and unsupervised, there are no such events happening. So you can classify the supervised learning into classification and regression, and in unsupervised, we have the clustering and associations happening. And most of the time, you can see in supervised learning, we have the accurate result, and in unsupervised learning, you may be having less accurate result, which may not be an appropriate result, but there will be some approximate outputs which may help the current design to improvise from the previous state. You can have some differentiations and find out there is a positive progress. And supervised learning is not close to the true AI, because we are training the model first and then helping the model to predict the output and to get it out. Unsupervised model is completely, you can call it as a project or true AI, because there is more learning happens. It has to work without the label data and without supervision. There is no prediction. output supplements. So without these things, then you have to do unknown data set. So supervised AI is a very important role in machine learning. Some of the algorithms in supervised learning, for example, we have the algorithm called as linear regression, logistic regression, multi-class classification, decision tree, and Bayesian logic. These are some of the algorithms which are popularly used in supervised. In unsupervised, we have this a priori algorithm, clustering algorithm, and KNN. These are the popular algorithms. So now we have come for the end of phase 2. That's about AI. So first we discussed about AI. The second phase is about machine learning. So under machine learning, we have 2 categories: supervised and unsupervised. So 2 of the phases. Now we have another 2 phases. One is Google Lambda, and the other one is how Vector is connected to Lambda. Now let's go to Google Lambda. So Google Lambda is a breakthrough conversation technology. So we would have about many chatbots. Can you name any chatbots which are popular, or any interaction systems which you are using in the phone or the computer? Can you name them? I was mentioning the different slangs what the people are following. So ancient Tamil scripts and the conversational language which you are practicing. There's a vast difference, and the patterns and the language used by people based on their regions are also different. As I told you, people from Chennai, they have different slangs, different patterns in language. Okay, so every word, the way they pronounce, the way they use that in sentence, everything is unique and different. So Lambda is a language model which is going to process a natural language. So this language model is helping us to analyze the use of language. So someone has said, I think, could you please mute it? I am getting some disturbances. Yes, okay. Yeah, if you have any questions, I'll handle in the end because I cannot see the chat window since I am sharing. So we are talking about Lambda. So
Sir, you are muted, sir. Vignesh, sir.
I was requesting to mute others, but someone muted me. Okay. Thank you, ma'am. Thanks for letting me know about it. So let me continue with the presentation. So we were talking about Lambda. So Lambda is a language model in, we were discussing about what is in processing a natural language, all those things with some examples. So this is a language model which is going to analyze the use of language. So it is, as we started, I was telling that this is a breakthrough conversation technology. So it is like you interact with a chat window or any automation system. The system will process your natural language and give you the appropriate answer. So most of the chat windows which you're coming across in our daily lives will have some expert systems which will store some predefined text or definitions or some paragraphs based on the words, keywords which we are questioning. Let it be a chat window where you will post some questions to an automatic chat box. So based on the keywords which you're giving, that particular chatbot will process and look for the keywords and match to the database and give you the output. Most of the time, we may not get the relevant answer. Most of the time, we are going to get only irrelevant answer. somehow some of the basic questions which does not have, or this does not need any computations, or which does not need any decision making skills, we might get the answer and we may feel that some of the basic questions were answered and satisfied. But think about some difficult questions or hypothetical questions. So how this chat window will handle us? So the answer should be catering the needs of the user. It has to give the required data, required information in their desired format. So most of the chat windows or chat boxes does not do it. Okay. So here this lambda, using many mathematical functions, it can predict the next word occurrence and even what is going to be the sequence of paragraphs might be. So this is one of the biggest feature that the Google has established. So this project they have launched initially in the year 2020 and at the end of 2020, and they were, it was improvised in 2021, and Lambda 2 was released in the year 2022. That is in the present year. So this Lambda uses OpenAI, Open Artificial Intelligence GPT-3 language generator. This is also one of the example for the language model, which will help you to process the input based on the instructions, and it can generate its own story. This is a story writer, short essay writer. So this is also handling many keywords and processing the syntax and semantics. That is what all about the English grammar and the vocabulary is handling vocabularies, and it can create a short essay or a short story. So similar to this Lambda is an improvised model than the GPT-3, because GPT-3 concentrates only on writing an essay. Here, this Lambda processes more of it, like handling the conversations and giving the answers, which is which predicts, or which proper prediction, and the answers are almost similar. I mean, similar to the human being answer. I'll show you some examples for that. So this Lambda has developed based on the OpenAI API, application programming interfaces, which has more than 300 applications. So GPT-3 is one of the applications. So this is to process the word processing and handling the text, vocabulary, semantics, syntax, and all. It's all about dealing the natural language processing, and it also have to make a perfect prediction. So predicting the word and predicting the exact word, or at least to the close approximation. So you may not get 2 plus 4 is equal to 6. You may not get 6 as 6 is a right and accurate answer. So 2 plus 4 is equal to 6. You may not get 6. Besides 6 is the accurate answer, you may get at least, you need to get at least 5.4 or 5.8 or 6.1. That will be a answer which is close to the accurate answer, or it is an approximate answer. So this Lambda sometimes may not give you the accurate answer, but it can give you close approximations. That itself a very good improvement happened in the conversation technology. So Lambda is different from the other language models because it was trained on dialogue, not on text. So more of dialogue conversations happens here, not on text or keywords. And this GPT-3 is focusing on generating language tests, and Lambda is focusing on generating dialogues. So this chat or conversation technology will help to improvise by giving the dialogue conversation rather than the text conversation. So Lambda is one of the large language models in the world. So this can answer your problems and solutions to your problems based on looking into the computations. It performs a lot of computations, and it can access billions of words across Wikipedia or Reddit or any other source of knowledge. So that too, the time taken for processing all the information is very short. So lambda can to the current need of resources and need of data, need of knowledge, and help you to improve this conversation technology. There is another application called as Palm, which is even bigger than Lambda. This is mainly for handling the mathematical problems and code generations. So this even more advanced processing system, and they more accuracy. But Lambda more of conversation technology, and it incorporates the dialogue, and they look for Lambda to be more sensitive to text. So I arrived at the as processed, encoded, and decoded, and so Lambda performs this step by step. This is a step by step analysis, which involves a transformer analysis to convert the complex language. Happening, and it should not be generic, rather it should be very specific. So this is what the outcome of the change that has taken place in terms of performance. So lambda is created to meet a series of metrics by human raters than the what the other chatbots are not doing, and they have this trouble with it. And the internal consistency, that is in the storage and the responses, and how the unexpected questions are handled, and what is the sensibility, specificity, and interestingness scores. All these things are analyzed with lambda. So I'll show you the scores for SSI, sensitivity, and interestingness, which Google has measured compared with the human their research and their work because of geometrical entities that are matched with the direction. So vector can be represented. So scalars have numbers. Vectors have that point of time. Denote nothing. Vectors are represented by at point. So typical patterns such as displays.
Or shall we continue?
end கொடுத்துருமா? end கொடுத்து end